So let's take a look at some reactions of alcohols. Before we even start naming or showing reactions for alcohols, we have to classify alcohols. So the reason we classify it is that each type of alcohol is going to react slightly different. So let's look at the first type right here. I'm looking at this carbon right here, and this carbon right here, the one bonded to the OH, that's the key. This carbon right here is bonded to one other carbon. So it's bonded to one other carbon. It's bonded with two other hydrogens, one other carbon. When that happens, we call it a primary alcohol. So we use that one notch, means it's a primary alcohol. Let's look at the second one right here. In this case right here, again, we're looking at that carbon bond directly to the OH. So this one right here. This carbon by here is bonded to two other methyl groups here, there. It doesn't have to be methyl, it could be any type of carbons in there. So in this case, I call it a secondary alcohol. Let's look at the third type here. This one right here, again, looking at that particular carbon right there, well, I got 1, 2, 3. It's bonded to three other carbons. It's a tertiary alcohol. Let's look at this one. So the cyclic ones are always going to be a little tricky with this. So the cyclic one right here now, I'm looking at this carbon right here. That's the carbon bonded directly to the OH. I call this carbon number 1. So let's call it 1, 2, 3, 4, 5, and 6. So carbon number 1 now is bonded directly to carbon number 2 and bonded directly to carbon number 6. So it's bonded to two other carbons, so it's called a secondary alcohol. Let's go ahead and let's try to figure out the classification for this one right here. Again, cyclic ones can be a little tricky here. So let's call this carbon number 1. So 1, 2, 3, 4, 5. So carbon number 1 is bonded directly to the OH. Let's circle it. And so carbon number 1, though, is bonded to this CH3. It's bonded to carbon number 2. And it's bonded to carbon number 5. So this, and this. Bonded to 3 carbons now, so it's a tertiary alcohol. And again, these things all react differently, as you'll see in a second. So this is why we have to classify primary, secondary, or tertiary. First type of reaction we're going to look at something we've done before. We're going to look at combustion. So combustion, basically, you react oxygen. So in this case, we have alcohol. And this is why they use alcohol and gasoline. So you have alcohol reacts rapidly with oxygen, and we're going to form carbon dioxide gas in this. So CO2 plus water, and you give off energy. So any type of alcohol undergoes combustion now. Carbon dioxide gas, water, and alcohol. Balance it. 3, 2, 3. So let's go ahead now. Let's look at the second type. Second type is going to be dehydration. So when you have dehydration, it means you lose water. So we're going to lose H2O. A better way of looking at it is you lose an oxygen, a hydrogen, and an OH. So, or we can say HOH. So one carbon will lose a hydrogen. Another carbon now will lose an OH. Let's go ahead and let's do one here. Couple of things when you're doing these, it's probably best to draw these out until you get accustomed to this. Again, you wish acid, we have some acid, which is H+, we add a little bit of heat. And what's going to happen is one carbon, so let's number this, carbon 1, 2, and 3. One carbon losing the OH, so the one with the alcohol loses an OH. And then we lose a hydrogen adjacent to it, so we lose this. We have to be a little bit careful with this. Sometimes it's just a little tricky to figure out which hydrogen we're going to lose. So I'll lose this and this. So when that happens is, carbon number 1 has lost an OH. Carbon number 2 has lost a hydrogen. Now remember, for all this now, is that carbon's got to have 4 bonds. To make it up now, it's going to form a double bond between carbon number 2 and carbon number 1. So they lose a hydrogen, they lose an OH. Now carbon is short of bonds, so now it makes a double bond with this. So basically, I go from an alcohol to an alkene. Let's look at another one. Now, in this case, this is slightly different because we got to make a decision which carbon to remove the hydrogen from. And again, it doesn't make a difference in what the product is going to be. So let's take a look at this one. This right here now, let's go ahead and number this. This is actually going to be 2 butanol. So carbon 1, 2, 3, 4. Notice that I kind of drew this out in expanded form to make it a bit easier to see. So obviously we're going to lose this hydrogen. This OH, sorry, that alcohol group. And then we got to decide, well, do I lose a hydrogen from carbon number 1? Do I lose a hydrogen from carbon number 3? The rule is, they call it SATSIF rule, is that we remove hydrogens with carbon with smallest number of hydrogens. So when I'm looking at this one right here, carbon number 3 has 2 hydrogens, so it has 2 hydrogens. Again, it has to be the one adjacent to it. Carbon number 1 has 3 hydrogens. 1, 2, 3, So I got to lose a hydrogen from carbon number 3, and then we'll form a double bond in between. So I've lost an OH, I've lost an H, I'll make a double bond to complete it, to make it 4 bonds. And then we're set. So now we're set with 2 butenes. So I'm going to go from an alcohol to a alkene. Let's go ahead and look at the last one for dehydration. So in this case right here is a cyclic one. So again, the way you do this, I will go ahead and number it, number each carbon first. So again, we start with the OH. So carbon number 1, 2, we'll name it clockwise, counterclockwise, 3, 4, 5, and 6. So again, we see H plus in heat. It's a dehydration. I'm going to lose a OH and the H. So I lose this OH. And then I got to decide, well, which carbon do I lose the hydrogen from? Again, we have a couple of choices. I can lose it from carbon number 6. I can lose it from carbon number 2. So we have to count up how many hydrogens are on each one of those, and the one with the lowest is the one we're going to remove. Well, carbon number 6, I kind of put it up there. So it has 2 bonds. It goes to carbon number 1 and carbon number 5. So it has 2 hydrogens there. A lot of times I draw out the hydrogens. Carbon number 2 now, well, it's got 1 methyl group, and then carbon number 3, carbon number 1, so it has 1 hydrogen there. Which means now, this is the lowest number of hydrogens. I'm going to lose this one. So I'll lose that. And then I form a double bond. One thing is, remember now, for all these dehydration, water comes off. I didn't draw it for the other ones, but water comes off with this.